All right, exercise 10p, question 3. So we've got a random variable x which is normally distributed. Okay, so we've got x normally distributed, and we don't know the parameters. But what we do know is that the probability that x is greater than 58.54, that is equal to 0.022, and the probability that x is less than 48.84 is equal to 0.012, and find the parameters. Okay, so let's draw a diagram of what we have here. And right, so mean unknown, and standard deviation unknown. Okay, no big deal. Let's get it done. Probably x is greater than 58. So this is a small number. So we're way up this end of town, aren't we? Up here somewhere with our 58.44. And in here is 0.022. Okay, but actually we're not interested in to the right of, we want it to the left of. So to the left of that, in a yellow color, right, this area to the left of and beyond all the way is 1 minus 0.022, which is, what's that, 0.978. Does that look right? 0.978. So that goes into our inverse normal function. Probably x is less than 48.84 is 0.012. That's an even smaller area down this end of town somewhere, 0.012. So in here we have, sorry, that's not 0.012, it's 48.84, and the area is 0.012. Struggling here, 0.012. Okay, and that should continue down here like this. Okay, hopefully that's clearish. So, so now we need our z values for these guys. So the z value for this guy will be found by getting into my calculator. I'll just find my calculator. Okay, so let's find menu 553 for inverse normal. Our area was 0.978. 0.978. Okay, 0.978 goes in here. 0.978. Z value 2.01409. 2.01409. I think that was right. 2.01409. Righto. So that's my Z value there for 58.44. Now my Z value for 48.84 is going to be inverse normal 0.012 for area. So let's go in there, 0.012, menu 553.012, tab, enter. Negative 2.25713, negative 2.25713. That's my Z value for 48.84. Making sense. Look at this. This is 2.25. The standard deviation is below the mean. Yeah, that looks perfectly plausible, as does this being just over 2 standard deviations above the mean, both at the extremes of my bell curve. Okay, so now I can form my two equations for mu and sigma and solve simultaneously. So I'll set those equations up now. So this value, so therefore out of this, if I continue my color coding, out of this I'm going to get that 58.44 minus my mean over my standard deviation is going to be equal to 2.01409, because remember that the difference between my score and mean divided by my standard deviation gives me how many standard deviations above or below the mean I am. Okay, so running this through, I will get mu equaling, I'm doing a few steps here in my head, but it's going to be 58.44 minus 2.01409 sigma. And over here in green, I'm going to have 48.84 minus my mean over standard deviation. In this case, it's going to be negative 2.25713, and I'm going to get mu as my subject again, which in this case will be over there 48.84, and this is going to be plus 2.25713 sigma. Okay, so now equating my two parts, so equate 1 with 2, put those guys together. So therefore, I will have 2.25713 plus 2.01409, which is okay. So collecting like terms and sorting out, I'm going to get my sigma here to be 9.6 divided by, I've got a calculator on the go here, 4.27, and I get 2.25 to 3 significant figures. And I can use that now to find my mu, so therefore mu is equal to 48.84 plus 2.5713 by this 2.2476. Use the calculator to display there. So let's calculate that, 48.84, which is exact, or it's a terminating decimal anyway, plus now my 2.5713, I can use that, 2.5713 times my 2.24, etc. It's going to give me 54.6 to 3 significant figures. 54.6 to 3 significant figures. So let's just see if that looks like it makes sense. 54.6 goes in here, and a standard deviation of 2.25, which would give me 54.6 plus 2.25. So it's in the region of 56.85, which looks absolutely spot on. So we can, I think, confidently go forward with those as our results.